Hello everyone, welcome to my channel. I am super excited to present this first video in our Solid Principles series. Today we will deep dive into the fundamental concepts of solid and focus on the very first principle, which is single responsibility principle. We will also explore a practical example which will help us understand this concept in detail. So now let's get started. First of all, introduction to the solid principles. Solid, it is an acronym that represents the five principles of object-oriented design. If we start following solid principles, our code will become more maintainable and flexible. This way, it helps the developers to design a software which is easy to maintain and extend over a period of time. Now we'll talk about the high level definition of all these five terms. Single responsibility principle. Here, basically, we mean that each class or module that is in our code base, it should be responsible for a single main task. It means that it should only do one thing. It should not have multiple things to be done by a single class so that it's easy to test our code, it's easy to modify our code. We are not having multiple reasons for our class to change. That is the primary objective. Open close design principle. The open close design principle basically states that our code it should be open for enhancements, for extensions, but it should be closed for modifications. Whatever we have written, we should extend our functionality rather than making more modifications into the existing classes. Third is Liskov substitution principle. It basically states that the subtypes or the subclasses that we have, they should be able to be used in place of their base types or in place of their parent types without even affecting the correctness of the program. So let's say we have a client who knows about a parent class and the certain behaviors which are provided by the parent class. The same behaviors, the similar methods should also be available in the subtypes. That is where the subtype is easily replaceable by its parent type without impacting the correctness of the program. Interface segregation principle. Now the clients, they should not be forced or they should not be basically forced to implement the methods which they really don't need to do. So we should not actually create bulky interfaces. Whatever is needed or must to have, we should have only that much in an interface. And we should segregate our interfaces on the similar lines. Whatever is needed, we should keep it as part of a single interface. Next is dependency inversion principles. The high level modules, which are basically the abstractions, they should not depend on your low level modules. So basically, what we want to say here is everything, whatever we are designing, whether the high level modules or the low level modules, everything should depend on the abstractions. Once we'll see an example on dependency inversion, we will get to know better about it, what we exactly mean by this. Now we'll talk about the benefits of solid principles. So if you have started using solid, right, how it impacts the software quality, the design of the software, we'll talk about those things. First of all, increased testability. When you are saying that you are following solid, right, means single responsibility principle, open close principle, risk of substitution, or let's say interface segregation and dependency inversion. The way we are testing our code, either by using the JUnits or by writing the integration test cases, it becomes very easy to write the test cases because we will have a smaller code with simpler responsibilities and more focused goals. And now the classes are easily testable. If we talk about refactoring, right, if we have a large code base, basically one class is responsible for multiple responsibilities. If we want to refactor such a code, right, it will take a lot of time and a lot of efforts. And after that, it will again require a lot of testing. If we are already writing our classes in a way where we say that one class is only responsible for one behavior, then it is very much refactored. But if needed, we can further refactor it. Now, code organization. We are saying that one class is having only one responsibility. We are not modifying our existing classes. We are only extending the behavior. That way, our code always remains organized, well structured. If we have classes with thousands and thousands of lines of code, it becomes very difficult to read that code. So the code complexity increases That is what we mean. Now, if we are following all these principles where we are saying that our class will not have multiple responsibilities, we are not making modifications to our existing class. By following all of these, we are reducing the complexity of our programs. Now, let's deep dive into single responsibility principle. S, which stands for SRP, is the first principle in the solid series. It states that a class should have only one reason to change. We'll discuss about it. What does it mean? In other words, a class should have only a single responsibility to complete. What does it imply? So basically, it helps our class to be focused. It makes them easier to understand and maintain and modify. So whatever we are writing, right, whatever code we are doing, it is easy to understand, only one responsibility for one class, and it's easily maintainable. And even if you want to modify, right, basically the behavior of that particular class has changed. It's very easy to modify it because there is only one responsibility with that class. We will discuss the scenario with a very simple example, which is very much relatable to everyone in the real life. And then we'll discuss about the Java code as well. Let's say you are going to place an order. So if while placing an order, right, what all steps you encounter, right, what all happens, that we'll discuss. So we are creating an order, right? If we are creating an order, then invoice will get generated for that order for which we make the payments. And once the invoice is generated, the next immediate step is you get some notifications, email notifications or SMS notifications, right? So let's understand the single responsibility principle with the help of an example. First use case would be when we are not following the SRP. So where the SRP is violated. So below code, I hope everybody is comfortable with Java. It's in Java. So below code, basically we are creating a class order and we are saying there are three primary responsibilities of this class. One is to create an order, wherein we'll have certain logic to create an order. Then second is we are saying we want to generate the invoice also for this particular order. And the last one is that we want to send confirmation email. So it could be an email, it could be an SMS notification, whatever. But yeah, there are three separate responsibilities which this class order is responsible for. That is exactly what SRP is against, right? SRP used to say one class, one primary responsibility. There could be some helper functions, but the primary goal or the responsibility should be single. So let's see how we can refactor this code now. So in this example, we have seen we have an order class. It is basically responsible for creating the order. It is responsible for generating the invoice. It is also responsible for sending the confirmation emails. So it clearly violates your single responsibility principle. Now we will say that we will refactor this code so that we have multiple classes and each class having one primary responsibility. We can have one class called order, which will be responsible for creating an order. We will have one more class, let's say invoice generator, which will be responsible for generating the invoice. And we will have one more class, which will be basically responsible for notifying the users. So let's say email notification class. Let's go down. So we have one class order, which is basically creating an order. Another class is invoice generator, which is generating an invoice. And now the third class is, let's say the email sender class, wherein given an order, it will send a confirmation email for that order. Now with this, right, we have seen that we were primarily having three different responsibilities, which were completely independent, given an order, different responsibilities, right? Having an invoice of that order, having a notification for that particular order. So now we have divided into three different classes. One is order, one is invoice generator, and the third one is your email sender class, which is sending the emails. That way, we basically said that where we were violating the single responsibility principle, we have changed or refactored our code in such a way that each class is following one primary responsibility. What are the benefits we are achieving? So it's very easy to understand this code. You would understand that now there is not a lot of code inside a single class. Every class having one responsibility, it's easy to understand. It's easy to make modifications or maintain your code. Another is you can very easily test your code. So the code is very well organized, readability increases, it's easy to maintain and debug your code, and now there is reduced impact to the changes of one responsibility. What does that mean? So now if we know that certain part of the functionality needs to be changed, we don't need to test the entire code, right? One class was having one responsibility, we are making certain modifications, right? So now we'll finally conclude. So this wraps up the explanation for our single responsibility principle. This was the very first principle in the solid series. Remember that designing classes with a single responsibility principle, it contributes to have more flexibility, maintainable code, readable code, and it's very easy to test such a code, right? In the next video, we will deep dive into O, which stands for open close principle. That's pretty much of it. We will upload this notes. We'll upload the code that we have seen in a GitHub repo so that it's easily accessible to everyone. Thank you, everyone. Thanks for watching. And don't forget to like it, share it, and subscribe it for more such insightful content on the Solid Principle series. Thank you. Thank you.